One question: is there a way to determine the maximum and minimum of a function by its graph and signs alone? Well, this video is the answer, because this channel provides only solution, so it means there's no problem. Today we'll be discussing the sign analysis of the first derivative test, and we have said that every relative extrema is a critical number, but not all critical number is a relative extrema. And the process of having this first derivative test is analyzing whether our critical points is a relative maximum, a relative minimum, or neither maximum nor minimum of a function. So our sign analysis process will be finding the critical number of the given function, and the critical number occurs at x, in which the derivative of the given function is either 0 or it does not exist. So for example, we have here a function. The graph of the function looks like a parabola that opens downward. We can say that this one has a critical point from x, in which the derivative of the function at this point here is equal to 0. So that's one case. While there are other cases in which a function, let's say for example a parabola that opens upward, we have also a critical point here from a critical number from the x-axis, and we can say that if this is the slope of the function here and represents the derivative, then the derivative at this point is also 0. Okay? But sometimes we have a function in which we have a critical point, but it is not a maximum and it is not a minimum. For example, this function, you will see that this is a critical point right here, and this critical point is not a maximum and not a minimum. So this one is neither max or minimum. Okay? So in other words, if a function has a derivative which is equal to 0, we are very sure that that number, that x value represents a critical number. But sometimes a critical point, just like this one, this is a critical point which also came from a critical number, but it does not represent any maximum or minimum part of the given function. Okay? So another one is, what if the derivative does not exist? So for example, we have a graph like this. This is a cusp or a corner, and we know that the derivative at this point does not exist because it is approaching different number from left to right. Okay? But this part here is a maximum. In other words, this is a maximum, but the derivative does not exist. Okay? Remember here, a function is either 0 or it does not exist. Another example, if we have a function which is like this, we have here a minimum, but the derivative at this point also does not exist. Okay? While if we have this kind of function here, let's say we have here a point and the derivative at this point also does not exist. But notice that this one here is not a maximum, so this is neither maximum nor minimum. Okay? Just like with the case in our previous analysis for the function which has a derivative of 0, it could have a maximum, a minimum, and at the same time neither maximum nor minimum. And also, if the derivative does not exist, we have also three cases: either a maximum, a minimum, or neither maximum nor minimum. Okay? So our job this time is to analyze the sign of the parts of the given function, because by those signs, we can say that a given function has a relative maximum, a minimum, or the other way, neither maximum or minimum. Okay, for example, I have here a function, okay, and this function is represented by this graph. Notice that in this graph, this is a parabola that opens downward. Okay, so at this point here, we can say that this is a relative maximum. Okay, so at this point also represents the slope of the tangent line, and the slope of the tangent line here is 0, so it means that the derivative here is 0 because this is a horizontal line, and the slope of the horizontal line is always 0. Okay, but this point here, whatever point is this, it came from an x value from here, which is, we have here the critical number, and this x value here represents a critical number, and this y value here represents an ordinate to have this critical point. Okay, so our job here is to analyze the sign of the derivative on the left of this critical point and to the right of the critical point. Okay, notice that on the left side of this critical point, say this is our critical point. Okay, on the left side we have here functions that are inclined from left to right going upward. So whenever you see slopes of the tangent lines to a curve that is positive, it means that our function is increasing. Okay, I will write here from this part of the graph that is increasing. So in other words, our sign of the derivative is positive. While from this point going to the right, we have here slopes that is inclined downwards from left to right. So it means that this part here, the graph is decreasing. Okay, and the sign of our first derivative is negative. Okay, so in other words, whenever you encounter situations like we have a sign of positive, then 0, then negative, we are assured that we have a relative maximum. Okay, please remember that positive, 0, negative, it will produce a relative maximum. Okay, the reverse of that is, what if we have a graph like this? Okay, and say for example, this is our x-axis. Okay, of course this is, by inspection we can say that this part here is a minimum. Okay, that is a minimum, and at this point also, at this point here, the critical point, that's the critical point, the derivative here is equal to 0 because our tangent line here to the curve is horizontal, so our derivative is 0. But take note, when we analyze the different parts of our graph here, starting from, this is our critical point, so from this point going to the left side, we have here a decreasing part of the function, so therefore our sign here is negative because it is decreasing. And from this critical point also going to the right side, the slopes are increasing. Okay, so our sign here is positive, so this is decreasing and this one is increasing. Decreasing is always represented by a negative sign, and increasing part of the function is represented by a negative sign, a positive sign. Okay, while here at the critical point, of course, that is 0. So our sign analysis, if we have this situation, it would be negative, then 0, then positive. So it means whenever you encounter the sign of the first derivative as negative, 0, positive, it means that we will produce a relative minimum. Okay, That is our sign analysis. Now, what if we have this type of function? Okay, suppose this is our function represented by this graph, and we notice that at this point there is a change from the behavior of our graph. Some parts here from the left side of this point, let's say this is our critical point, okay, the behavior of the slope here of the tangent line to a curve is increasing. They are increasing, so our sign here is positive. At this point, to the critical point, okay, this one came from the x-axis, so the critical point has a critical number, and that critical number came from the x-axis, of course. So at this value of x, the derivative is, of course, this one. What is the slope of this tangent line? That is 0, of course. So the derivative here of our function is equal to 0. So positive, 0, and to the right side, we have here still increasing, right? So still we have a positive. So in other words, to the left side of this critical point, our function is increasing, right? Okay, and to the right side of this critical point, still our function is increasing, so it doesn't change, and our sign analysis will be positive, 0, positive. Okay, positive, 0, positive. So in that case, whenever you have positive, 0, and positive increasing, it does not decrease, so our sign analysis will be, it will produce neither a maximum or a minimum. So there is no maximum, there is no minimum. If there is no change in the behavior of the graph, it will continue to increase. Okay, the reverse of this is, of course, if we have a function which is represented by this graph, obviously we have here our critical point, and to the left of the critical point, where is the left? For example, this is our critical point. The left of the critical point is here. And what's the behavior of the slopes here? It is decreasing, right? So we have a negative sign. At this point, we have a horizontal line. So our derivative here is equal to 0. Okay? And at this part, after the critical point, still our slopes are decreasing. So in other words, our sign analysis would be negative, 0, and negative. Negative means decreasing. Okay, I will write that one so that you will remember always. Decreasing, and this one is still decreasing. So negative, 0, negative, decreasing, 0, negative. Still we have the same sign analysis. This one will produce neither a maximum nor a minimum. In other words, there is no maximum, there is no minimum, because the behavior of the slopes of the tangent line of this function is decreasing all throughout from left to right of our critical point. Okay, so that is the situation. What if we have a function which has a derivative which is DNE? DNE means does not exist. For example, let me illustrate to you with a simple graph like this. At this point, we are very sure that this is the minimum. And if this is the minimum, it means that our derivative here of x does not exist. This is a corner, this is a cusp, this is not a curve. So our derivative here is not 0, but it does not exist. But when we analyze the slopes of the tangent line to the left of our minimum point, that is the critical point, okay, this one is decreasing, right? Decreasing. And after this point, this is increasing. The slopes here are increasing. So what will be our sign analysis? Our sign analysis will be what is decreasing, negative. At this point, the slope is 0. The slope does not exist, rather. Okay, let me write that again. Okay, the slope here at this point does not exist, dNA, and we have here increasing, positive. So if we have negative does not exist, positive, it means that we have a minimum. Okay, another case, if we have a situation like this, say for example this is our graph and this is our critical point. Of course, the derivative of the function at this point does not exist also because that is a corner. But notice that from the left of this critical point here, the function is increasing. Okay, the slopes of the tangent lines here to the curve of the function are increasing, and after the critical point the slopes here are decreasing. Okay, so in other words, our sign analysis in this case will be positive, 0, and then negative. Okay, so if you have a positive sign of the derivative changed to 0 and then negative, we have here a maximum. Okay, so by the graph alone of the function, we can analyze its signs, and it will give us an idea whether our function has a minimum, a maximum, neither maximum or minimum. Okay, the last sign analysis that I would like to show you is the case of also of a function in which the derivative does not exist. For example, I have shown this graph before in the previous video. For example, at this point, this is our critical point, and we know that if this is the case, we have a corner, the derivative of that does not exist. Okay, so the behavior, however, of the tangent lines here to the left of the given critical point, this one is increasing. If that is increasing, its sign will be positive. At this point does not exist, and after the critical point here we have still an increasing slope, so still we have positive. So our sign analysis here will be positive, does not exist, and then positive. So this one will produce neither max, not a maximum, and not a minimum. Okay, let me go back first to our previous analysis, and I realized that this one should be changed to the dNA, does not exist, it's not 0. Okay, and here in our last illustration, the reverse of our function, like this one, notice that at this critical point the derivative of the function here does not exist, and same as before, we have here decreasing behavior of the slope, so that is negative. Okay, and still here we have decreasing slopes, so we still have negative. So our sign analysis will be negative, does not exist, then negative, and this one will produce also neither max, not a maximum, and not a minimum. Okay, so I hope that this video helped you, that the idea on which the sign of the slopes of the given function will give you the clue whether the function has a minimum, a maximum, or neither a maximum nor a minimum. Thank you very much, and see you soon on the next video.